All right, welcome to .NET development in 2025. I don't know what that was. Yes, so I'm David Gardner. I'm a senior developer for 6pivot, and I've been using .NET for a very long time. In fact, as long as the age of my eldest child, which is interesting, who is now married, so that'll give you some idea. But yeah, a quick show of hands, who has not used .NET before at all? Yep, a few, that's okay. That's good. I'm glad you've come to find out a bit more. Who's maybe used it a tiny bit, maybe did it in a course or playing around with it, but not seriously? Yep. Who's been using it for a few years? Yep. Who's been using it for a really, really long time? Yeah. That's good. So we've got a nice range of experiences. So I hope this talk you'll all get something out of it, both for those of you who have never used it before, right through to those who've been using it for a really long time. There's so much you can do with .NET that I'm hoping there'll be something that you come away with, oh, I didn't know I could do that, or I need to find out more about that. So the outline for the presentation part of tonight is as follows. I'm going to give you a bit of an overview of what is .NET, how does it work, what are the tools you can use to work with it, what languages it has, some of the libraries that it comes with, how to get started working with it, and we're going to give a quick demo of all the different kinds of applications you can build with it. Following that, we're then going to sort of finish up the presentation up the front, and then it'll be a chance for you to all have a play on your laptops and try out some of the tutorials that we'll let you know about then. So let's dive in. So .NET is a development platform. It can create a whole lot of different kinds of applications like cloud, web, desktop, mobile, gaming, IoT, AI, a broad range of applications there. We've got different tools we can use to develop with it. It is cross-platform, so it runs on Linux, Mac and Windows, and it's got a really rich ecosystem of first and third-party libraries that we can use to build our applications with. So why would you consider choosing .NET? One good thing is it's free, so it's free to develop with and it's free to build applications and publish those, so there's no licensing cost to use .NET. It's open source, so it's managed by the .NET Foundation, which is a non-profit, and all the source code is up on GitHub. And the members of the .NET Foundation include Microsoft and Google, JetBrains, Samsung, Unity, are probably the bigger names, but there's other smaller companies and even individuals can be members of the .NET Foundation. In fact, even myself, I've sort of signed up as a member. It's fast. The Tech Empower benchmarks, if you look at those, the first few on all their benchmarks are really sort of highly customized, really specialized solutions that have probably just been written to beat everyone else on the benchmark. The best performing general purpose development platform is usually .NET. It's right up there. So it's one of the highest performing general purpose development platforms. It is cross-platform, as I mentioned, so some people think, oh, .NET, that's just a Windows thing. Well, that used to be the case, but not anymore, and not for a few years now. It's now cross-platform. We can build on different platforms. The languages are also active and evolving, so there's new enhancements to the languages that are coming out each year, and yet they're also very good at keeping things backwards compatible. The code that you wrote years ago almost certainly will still compile and be able to be brought forward to the latest versions. And it's supported, so if you do want commercial support, you can purchase that, and Microsoft can supply that as well. So a quick history of .NET. So it started out way back, and you now know how old my oldest child is, in 2002, when the very first version of .NET Framework came out for Windows only. and it was not open source. So it was a closed source solution that Microsoft built that only ran on Windows. And there was a number of releases of that came out, always only on Windows, until 2016, when the first version of .NET Core came out, and that was the first open source cross-platform solution. That's okay. A bit of a tip, don't change the colour of your slides at the last minute, because you can't read the text in the middle there. What that says, I think, is there was the last version of .NET Framework 4.8 came out in 2019 from memory, and there was a .NET Core release as well. Because .NET Framework, the Windows only version, that's not going to be sort of worked on really, apart from security fixes. That's pretty much just left alone. So the new version of .NET now, they've simplified the name, just calling it .NET, and so each year there'll be a new version comes out in November. So in 2023 we had .NET 8, and that's the current long-term servicing release. So that gets 3 years of support. Last year there was .NET 9 came out. That's a short-term servicing release, so that'll get 18 months of support. And this November we're looking forward to .NET 10. That'll be the next long-term servicing release. So long-term servicing releases every 2 years, and they get 3 years of support. So if you're concerned about putting something into production and it being really stable, they're probably the ones to pick. If you like being on the leading edge and taking advantage of new features, then you're probably going to upgrade each time a new version comes out. So how does it work? Well, good question. So we're starting off with some source code in a particular language that .NET supports, and so we've got an example there. And then we're going to build that with a compiler. So we've got a command line that's getting run here in this case, and that's going to generate what we call intermediate language. I guess if you were used to Java, then you might think of it as bytecode, the same kind of thing. It looks a bit like assembly language, but it's not actually targeting a specific architecture. It's a generic hardware agnostic solution. Come in if you're here for .NET. If you're not, then no worries. And so that's going to create what we call an assembly, a DLL file with that in it. We can then combine that with other assemblies, either from other projects that we've built as part of our application, or from third-party packages. And then we've got our application compiled and built. We want to run it, so it's going to run in the .NET runtime. So the runtime is all about sort of enabling an object-oriented model to run with types and classes. It's basically like a virtual machine. It provides memory management with a garbage collector. It has a JIT compiler, so it'll take just in time the IL, the intermediate language, and turn that into native machine code. So if you're running it on an Intel, then it'll probably turn it into x64. If you're running on an ARM processor on a Mac, it'll turn it into ARM machine code. So that's then going to run fast on that machine. The runtime also provides things like a common type system, so we can actually combine different languages, and as long as they're using the common type system, they can talk to each other quite easily. There's asynchronous support, generics, exception handling, and reflection at runtime as well. So what tooling can we use to build our .NET applications with? We've got a few different choices. In the top left, we've got Visual Studio. So if you're on a Windows machine, you can use Visual Studio from Microsoft. There's a community edition, which is free, or you can pay for professional or enterprise versions of that. If you are not on a Windows machine, or even if you are, top right is JetBrains Rider. That runs on Mac and a Linux machine as well as Windows. That is, I think, is there a free version of that, or you've got to pay for it?
No, it's free for non-commercial.
Yeah, so if you're just trying it out, that would be a good one to have a look at. There's also VS Code, bottom left. So it's more of an editor, but you can add an extension to add support for .NET into that. And you could even use Notepad or just a plain old text editor. So I have actually seen a guy years ago who did a presentation and all he used was Notepad, and he just knew the stuff in his head. He wasn't relying on all the fancy help from the editor and the syntax highlighting, and he got it right. It was really impressive. I'm not doing that tonight, so. But yeah, there's some choices there. What languages have we got to use in .NET? Well, we've got one of my favorites from way back is Visual Basic. This is how I got introduced to .NET. So, and I think a lot of, let's say, more experienced programmers who work in .NET might have been the same as me, where they were already using Visual Basic VB6 for desktop, or myself, I was building websites with classic ASP with VB script. Or you might have been building Office macros in VBA as well. So choosing Visual Basic made a lot of sense for these kind of people because the language looked really similar. It's still supported, but I will be honest, it's probably unusual to see a new project adopting VB these days. It's more likely that it's just one that's already been VB and it just needs to be maintained that way. Or if you've got a team that only know VB, they don't know some of the other languages. But yes, it's there, but it's also easy, as I've mentioned already, if you've got projects written in Visual Basic, it's quite easy to work with them with other languages. You don't have to just throw it all away and rewrite it. The next language worth being aware of is F#. So I mentioned that the runtime is sort of focused around an object-oriented sort of way of running things. F# is a functional language, and you might say, hang on, functional, object-oriented, they're sort of opposing each other. Like, what are you talking about? Well, F# is functional, and like functions are a first-class element of F#, but it's been written to run in the .NET environment and work with types that are in the .NET runtime and work with other languages. So even though we can have a very functional kind of program here, so I've got functions being defined and I can pass functions into other functions. I'm not an F# developer, so but I can kind of figure out what this is doing. It's sort of printing out some stuff to the console. One of the tutorials, you'll get a chance to have a look at that if you want to learn a bit more about F#. But yeah, if you like functional programming, then F# could be well worth a look at. But finally we come to C#, and it's probably the most popular language used in .NET. Now if anyone's worked with Java or C or C++ or JavaScript or TypeScript, any kind of those curly brace languages, C# is going to look very familiar. So it's from that sort of same ancestry, if you like. So the most simplest program was this one. It's just a one line, and we're just printing out hello world. That's about as simple as you can get. But under the hood, the compiler's being nice. It's actually generating this for you. So you could write it this way, and this is how we used to do it. There's a class there with a method on it, and then we're calling that console.writeLine. We can get a little bit more complicated. We can start creating other classes inside a namespace. This is a private field, and there's a public property called age that's referencing that private field. I've got another property down here, name, that's got a getter and setter. It has it doesn't need to have a separate field because it's provided for us automatically. I could add other methods to that class as well to implement more functionality. Then I can use that class now in my program. So I'm creating a new instance of that person class. I can either declare that explicitly with using the person type, or I can use the var keyword like I've done there. And that's still strongly typed. It's just inferring the type from the assignment. So it knows that the John is a string, so that first name will be a string type. I can assign values to those properties. I've got a for loop there. I can loop over and assign and increment the value, output that. So if you've worked in any kind of sort of curly brace languages as I described them, then it should be pretty easy to pick that up. So then it's all very well to write code, but almost inevitably we need to call out to other libraries to get our work done. So there's a whole lot of libraries that are built in to .NET, the .NET runtime. It's kind of hard to see all of these. These are all the different namespaces that are in .NET itself, just built in. So anything like a string or an int, those intrinsic types are going to be in the system namespace. It's kind of hard to read where they've got the highlight there. We've also got types that are around collections, so things like dictionaries, arrays, lists, hash sets, all those kind of things. There's types there for you to use out of the box. There are types to do with I/O, so if you need to read and write files to disk, or if you need to access networking, different protocols, that's all built in as well. We've got types to do text, sort of encoding, but sort of converting between different encodings like ASCII and Unicode, as well as JSON, parsing and generating, as well as XML, and we've also got reflection. I can't even read my own slides there. Oh no, that was threading. So yes, there's built-in support for creating sort of asynchronous code and tasks and threads, and the XML I mentioned already. Sorry for the highlighting colours not being visible. That's all the stuff that's built in. And then you've got other libraries you can add on top of that. So if you want to add in some configuration or logging or some of these other features, there's a few extra extension libraries that Microsoft have created, but you don't have to use those. There's also a whole lot of others we can get as well from NuGet. So like a lot of other ecosystems, there's a package manager for .NET. So for Node, we've got NPM. For Rust, we've got crates, I think it is. So for .NET, we have NuGet. So there's NuGet.org is the website, and there's over 400,000 NuGet packages up there. Some from Microsoft, but also some from a lot of other sort of well-known companies that are providing features to be able to work with their things. So like AWS, Azure, Google. There's sort of unit testing frameworks like XUnit. Newtonsoft.json is a very popular JSON parser. Yeah, but obviously I didn't print out all of those. There's a lot of them there. Okay, that's enough slides. Let's get into some demos. So first up, we're going to install .NET. I'm going to demo this for you. And I'm going to switch over to my console. All right. So I've got a Windows subsystem for Linux, Ubuntu running here. It is Ubuntu 2404. Is that big enough? Everyone can see that okay? That's all right? Okay. And I don't have .NET on here. So just to prove that, I'm going to type in .NET. I'm going to spell it correctly. It doesn't know what I'm talking about. So how do I install .NET on this? Well, let's go back to my slide and click on a link. And let's drag my browser over. And so this will be part of the hands-on stuff we do a bit later on. So I can drill down here. Okay, I'm installing in Linux and Ubuntu, and click on that install page there. And I can choose my distro. And if I scroll down here, I am using 2404. And if I want to install version 8, which is the current LTS version, it actually says that's available built into Ubuntu. Excellent. But if I wanted to install .NET 9, I would need to go down here and add in an extra repository into the apt-get thing. But I'm just happy with 8 for the demo because it's easier. So I don't have .NET, so let's install that. So I can see what version is available. So I'm going to apt policy.net SDK 8.0. Okay, so there is 8.0.114. I think, yeah. So that is the one that got sent, that got made available overnight. So then I can do a sudo apt install .NET SDK 8.0, and I should have. Okay, that should be pretty quick. I did cache those files so that we didn't have to wait for the download. But that is now installed, so I can type in .NET, and it seems to know, and I can do .NET. Yeah. Info, and it'll tell me all the versions that are installed. So I've only got one version of .NET. You can install multiple different versions, so you can have .NET 8 and .NET 9 installed at the same time. So if I make a demo directory, and I'm going to create a console application just to prove that it's working. So I'm going to go .NET, there, new console, and it's going to create a project. And so I can open that in VS Code, and we can have a look to see what it's created. And I'll just bump that up to my screen here. So it's created a couple of things. It's created program.cs, and you'll see that by default it's just that single line. Bump that up a bit bigger. Hello world. I can change that if I want to. And it's also created this csproj file. This is an XML file, and this just helps the compiler know what we're trying to build. So it's telling the compiler that we're trying to build an executable, what version of the framework we're asking it to use, and a few other things that, yeah, we don't need to worry about today. If you start adding other package references, then you'll see them added to this file. If you've got other projects that you're going to reference in this project, then you'll also see those references added to this file as well. So this file will tend to grow a little bit, but yeah, for the most part you don't need to worry about it. The tooling will normally take care of that. So I've got my code here. If I go back down to my command prompt, I can build that by doing .NET build. That's going to basically run through that process we talked about earlier, where it takes the source code, generates that intermediate language. So it's built it, but it hasn't run it. So if we want to run it, well, we just do .NET run. And there we go. So that's taken that intermediate language, turned it into machine code, executed it inside my Linux machine here, and I've got the output there. So yeah, so we can now sell our application and make millions of dollars. So, or maybe not. But yeah, so that's installing on Linux as an example. Okay, if I go back to slides. Okay, okay, we've installed .NET. What can we build with .NET? Good question. First of all, we can build web applications, and there's a whole lot of different kind of web apps we can build. So we're going to have a look at some of those now. So we've got ASP.NET Core, Core MVC, Core API, and Core Razor Pages, and Blazor. So if I'm going to jump over to, I'm going to use Visual Studio for this demo. Where's my mouse gone? Oh, there it is. Okay, so this is Visual Studio. I'm on a Windows machine, and I'm just going to open my web demo. I'll give this a second to load. And then I'm going to basically launch all these web applications at once, so then we can step through and have a look at them. Okay. So there's a whole lot of console windows popping. You can't actually see it on my other screen, but there they are. So I've got about, was it 6 different web apps running now. So let's step through them. So first of all, we've got an empty sort of ASP.NET Core, like the most basic web application you can build. And this is using the sort of minimal approach where we're And it's basically 4 lines if you ignore the console title, which I added in just so I can tell them apart. It's 4 lines of code to create a web server, essentially. So it's just listening on the sort of the root level, and it's just going to return this hello world text. So if I jump over to my browser, and I'll bring this one onto our screen as well. And so that is this one. So there's a hello world. So it's just plain text, not even HTML. But obviously we could return HTML if we wanted to. So that's really simple. And if you've got a really trivial solution, then that might just be do the job for you. But quite often when we build web applications, they're a little bit more complicated than that. And so adopting something like the model view controller approach may make more sense, where you're separating out the different concerns. So in this case, we've got a controller class, and inside that class, we've got different endpoints, which represent our different pages in our web application. And the controller is then responsible for, if necessary, passing the model, which is any data that we need to provide, to the view. So that's the M, V, and C in model view controller. So there's an example here, the error page. We're returning a view, but we're also passing in the error information to that view. The view pages, we can see those in the view folder, and I'll show you the error page here. So this is what we call sort of Razor syntax, where it's mostly HTML. So if you've done any web development, that should look very familiar. But you'll see that we can actually reference that model that's being passed in, and then we use this @ notation to actually insert, or it's basically like data binding, if you like, that model. So this is all happening on the server, and then that the generated HTML is then passed to the client. So if I have a look at that web page in our browser, in MVC, so there's our web application. I can jump around between different pages. If I look at the source, there's a whole lot of HTML there and a bit of JavaScript as well. So that's MVC. You think, okay, well I don't need quite that much complexity, but I like the Razor pages. Well, there is ASP.NET Razor pages, which is kind of like a mix between the two, where you've got your Razor pages, and they still look pretty similar, but you don't need the controllers. So that's just a little bit less complexity. So if you like Razor but you don't want to worry about controllers, then there is this option to use just Razor pages. So you're basically mixing HTML, and this is C# in these little blocks here. So you're mixing those two languages together. So that's the main sort of ASP.NET web applications. But we have a couple of others which are a bit different. So there's this thing called Blazor, and I think John actually did a talk on Blazor, was it last year or year and a half maybe ago? I think the recording for that is up on YouTube. So Blazor is an interesting model where it combines this idea of the Razor pages, so we can see those here, and sort of mixing in some C# as well. So we'll see that rather than having to use JavaScript, we've got C# code in here. And if I have a look at that application running in the browser, then I think it's this one. Here's our application. I can click on that, increment that count. If I look at the source code, wrong one, sorry, ignore that. I think it jumped around, it's this one. They look very similar. I can increment the count. There is a weather thing there too. Don't think that temperature is accurate. But then there's a whole lot of HTML here. So as far as the browser is concerned, it's just another web app. All good. The second model of doing Blazor is kind of similar in that we've still got Razor pages. But have a look at the functionality here. We've got C# code, but this is now going to run in the browser. So because it's going to generate WebAssembly. So the compiler will turn the C# code into WebAssembly, and that'll run in the browser. So if I have a look That was actually the first one we looked at here. So it's running, I'm clicking on click. That's not going back to the server, it's just all running in the browser. And if we look at the source code, you'll see there's a lot less here because all the rest of the functionality is running in WebAssembly. So yeah, if you want to build something that runs in WebAssembly and has extra functionality, especially if you like writing C# code and you don't want to have to worry about writing JavaScript, then that model of Blazor could be useful. Okay, and yeah, one other mention, oh sorry.
Down there.
Oh, hi.
Yeah.
Yeah, so how's the C# performance running on WebAssembly compared to JavaScript?
So the question is how does WebAssembly perform compared to JavaScript, essentially? John, put you on the spot. Does it perform, is it as good as JavaScript?
How does Blazor WebAssembly perform compared to JavaScript?
Yeah.
I would say differently. I don't know the exact benchmarks, but the way Blazor WebAssembly works is that it actually uses mono that's been compiled with something called mscripted.
Yeah.
So they've taken the mono, all the C++ code, and they've run it through a compiler to build a version of .NET that can run in WebAssembly. And so what that means is not only is you've got a virtual machine that's interpreting WebAssembly, that's also got a virtual machine within it interpreting .NET bytecode. So you've got two levels of virtual machine-ness going on. So my gut feeling would be that JavaScript is faster than Blazor WebAssembly on the first run when you do something. On the second run, there will be optimizations at the mono level and also at the WebAssembly level with just-in-time compiling.
Yeah.
So I would say the footprint of Blazor WebAssembly is much larger than a JavaScript application, but performance-wise, you might find it could be around the same, but probably not. It's too hard.
It's probably something you need to do.
Yeah, I haven't measured it.
Yeah. No, thanks, John. Also mention of a library called SignalR. If you're building anything with sort of a real-time communication, or you need to polling, like a chat application where you need to let people know someone said something, that SignalR is really good at that. So check that out if you're building those kind of applications that need sort of notifications or things in your web page. Next apps we'll look at are desktop apps and sort of native apps. So let's jump back to VS and so we've got a few different things here. So first up, we've got WinForms. So this is a Windows only application model, and it's sort of been around since the very earliest versions of .NET, and it has, I guess one of the nice features is it has a design surface in it, which hopefully is going to work for me today. So we've got a form here, and I can then pin my toolbox, and I've got all these different controls, and so if I want to put a button on there, I can drag that onto here, and I can make it really big because I'm a developer, not a designer. And I can double click on that, and then I can add some code behind that. So I can do a message. Yeah, so it looks good. And so I can run that. And so the nice thing about WinForms is it's really really quick to develop something. And I think a lot of developers kind of like it just for that reason. You can just whip something up really quickly that's got a UI. It may not look pretty, but it does the job. You can spend a bit of time and making it look pretty if you want. So there's my form. It's got a button. Hi there. So that worked. That's good. but yeah, Windows only, so that could be a problem. And that's all, the UI is all in C#, so even the design surface, it's all generated C# code behind the scenes. So the other model for Windows only development is WPF, Windows Presentation Foundation. So the change here is that rather than using C# for representing the UI, that's flickering for you as well, that's awesome. We've got, whoa, I don't know why it's doing that. Let's just hope that something's not going to blow up. We've got XAML, which is an XML language for our markup language. So, it's settled down. It's XML, so it's a little bit like HTML, but it's a bit more strict. It's also a bit more functional as well. So I've got here a grid with a stack panel, and I've got a button inside that. So I can add another button in there. I could use a different kind of layout control. So the nice thing about this is it's flexible, so it works on different screen sizes and DPIs, yeah, you get a really nice experience. So I could add another button, or maybe a label, or a text block. Sure, let's do that. If I want to run that, and I'll just drag it onto the screen. So here's my WPF app. I've got a button. I didn't wire up anything to click, but yeah, it's nice, and I can resize that really easily. You can do the similar sort of things with WinForms. It just requires a bit of extra effort to get the scaling, but WPF just does that really easily. But yeah, only Windows. So no good if you're wanting to do something cross-platform. However, there is something called MAUI, which is cross-platform. So if I set that as my starter project. So again, this is now using XAML as well. So there's my XAML. It's sort of got a markup with different labels there. And if I run this, this actually supports Mac and Windows and Android and iOS. And so here's my Windows version of that. I've got a button here. That's kind of working nicely. Now there's one platform I didn't mention. Anybody pick which one it was?
Mobile?
No, so it does iOS and Android. I'll expand the platforms folder here. Which one's not there? Linux, yeah. So it's not there, and I don't know why, but there are solutions to that, but they're sort of, MAUI is provided by Microsoft, basically a sort of a first-party solution for .NET. But there are two third-party solutions for building cross-platform apps that also run on Linux. The first one is called Avalonia. It also uses a XAML sort of approach, a markup to generating a UI. But you can also build Linux applications and WebAssembly applications with it as well. So here is my Avalonia app. It's just kind of simple, but obviously I'm not a designer, and you can obviously do a lot more complicated UIs with that. The other choice is a product called Uno Platform. I do have that on my laptop. I'm not going to demo it now, it just requires reloading Visual Studio. So if you're interested in that one, we'll have a look at that later if you like. But that also allows you to target Linux and WebAssembly. So it's got a much broader target, sort of device target, if you like. So yeah, that's sort of desktop and mobile apps. Next one is cloud. So we can build stuff that runs in the cloud. That could be just something that is running in a container, and then you could pretty much run it on any cloud, or it could be something specific to a cloud. So for example, if I'm deploying to Azure, Azure has this idea of an Azure function. So I'll switch projects. So I've got an Azure function here. I've got some C# where I'm just defining a HTTP trigger. So in this case, the trigger is just going to be if I hit an endpoint, it's going to return something, a bit like a web server. But my trigger could also be a timer or when some other external event happens, like when someone drops a file in a storage account. And I can run that locally. Everything keeps running on the wrong monitor. So there's my function running locally, and I'll end up, I've got my HTTP endpoint here. I can click on that, and in my browser there's the text that gets returned from that. So yeah, I could add other functions into that, and then if that's working correctly, I could then obviously deploy that into the cloud. So there's similar things for the other cloud vendors with whatever sort of models they have. Yeah. And then we can build games. So I am not a game designer or a game developer, but I'm here to announce that I built a new game, and I'm hoping I'm going to make a lot of money out of it. So here's my game. I'll just bump it over to the right screen. If anybody is... So this is Unity, and this is my game. It's called Spinny Cube. There it is. I'm going to sell that on the App Store and make millions, but I won't forget all the little people when I'm really rich, okay? So don't worry. My daughter did study game design. She wasn't impressed, so not to worry. But this is using .NET, so this is the cool thing. So I've got a cube there. If I have a look at that cube, we'll see down here there's this thing there, and there is some .NET code there. If I double click on that, it's going to open Visual Studio, and I'll just bring Visual Studio over to the right window so you can see it. So if you're building games in Unity, then the scripting language it uses is C#, so .NET. So here's the actual logic here that's causing that cube to spin around as a rotate function. I could change that if I wanted to, but I won't because I don't know what I'm doing. But I can go over here and I can actually change the parameters. If I go down there, I can say rather than that, I'll change that to a different number. And so they're the numbers that are getting passed into that function. Hit play, so it's going to rebuild everything and run it. And whoa, even more exciting. So hours of fun. But yeah, obviously Unity is used to build commercial games. So if you know what you're doing, you can build proper games with it. I don't know what I'm doing. You can tell that. But yeah, so that's Unity. That's the one I had to play around with. I know a couple of the guys have been playing around with one of the other libraries, which is called Go. Oh, I've lost my place in the talk. Sorry, bear with me.
So I can talk about Godot for a second.
Yeah, John, talk about Godot, which is another library.
Godot is an open source game development framework that I've only been playing around for a couple of weeks, and I'm not a game developer either. But from what I can tell, it's very similar to Unity, in which it's got this object model. It's all based on nodes. And out of the box, it doesn't have .NET and C# support, but you can download a separate edition. So there's like the Godot Standard Edition, where it uses a different programming language called GDScript, which feels a bit similar to JavaScript to me, and cross between Python. And then it comes with a different edition called Mono, or .NET Edition, that'll let you use C# with it. The C# IDE in the Godot editor itself, it's not very good. I'm just cooking up something at the moment, like a breakout game. I'll probably get it working by the end of this and show everyone. But you can also get a C# extension. A VS Code extension for editing Godot resources.
Yeah, nice. Yeah, so that's one of the other engines, and there's a few of these other. I've got no idea if these are any good or not, but I guess if you're into game development, you'd have a bit more of an idea of what they're good at doing. So that's games. If you're working with data, then we've got a few different ways we can do that in .NET. The most popular object relational mapper is EF Core, or Entity Framework Core. I'll do a quick demo of that. We've also got other libraries we can use as well, depending on the database. Not that one. Sorry, that one. So I've got a database running on my machine, and I'm going to use EF Core to load data from that. So the way we do that is I've got some C# here. I'm going to create a new AdventureWorks context class. So let's have a look at that. So this is a class that allows us to map our C# classes to in this case, a relational database with tables in it. And so I'm going to map to those tables. So I've got an address type here in C#. If I drill into that, then I've got what's called an attribute that says this class maps to the address table in the person schema in the database. And then by using that, it can query the database and pull the data back into this type. So in my program, I'm pulling all the data out of the addresses table, and I'm just dumping that out to the console. So if I run that, assuming my database is running, which it is, then it's just pulling the data out and just looping and just keeps doing that over and over again. So yeah, so it gives us that being able to work with the data in C# in our classes, how we're used to working with things in .NET, map that back to the relational data in the data store. But yes, obviously, if you're using other databases, you can still use EF Core with that. If you want something that's more powerful, Dapper is all about performance, so there's an overhead for that sort of object mapping. But other database servers as well have their own SDKs if you need to sort of drop down to get extra performance. We can build IoT devices, we could if we wanted to. We can deploy to IoT devices, and I don't have one here today, so I won't demo that. But if you had a Raspberry Pi, you can deploy .NET to that, or one of these other IoT boards. There's also a thing called the .NET Nano framework, which is basically a really cut down version of the .NET libraries designed to run in a very constrained environment. So some IoT devices have not much memory, so having a smaller framework makes sense for those. And finally, we can build AI as well. So we've got a few different ways we can build AI into our applications. I'll quickly run through those. I know we're sort of running a bit over time for the presentation part, but just very quickly. So large language models are kind of all the rage at the moment, and we can interact with those in .NET. One way we can do it is using a library called Semantic Kernel. So this is a kind of like an abstraction over different large language models, and so we can then indicate which ones we want to work with. So in this case, I'm using GPT-3.5 Turbo running in OpenAI in Azure, but I could equally be pointing it to some other large language model running in some other environment. Having that in place, and I do have an instance running in Azure that this is going to talk to. Sorry, wrong demo. Start up. So this is going to launch a chat application. So there's my prompt, and I can say hello, and it's going to get a response back. Yeah, so obviously it's just like chat. If you could ask it something a bit more intelligent, it would do something. We can also use the SDK directly. So I've got the OpenAPI SDK here. So rather than using Semantic Kernel as a a higher level abstraction, I could just go straight to OpenAPI SDK and run that. If you want us to do that, I guess it probably depends how likely is it you're going to sort of switch between different models. So in this case, it was sort of supplying some text which caused that model to reply in pirate language. So I'm using. And finally, we have an example of using a library called ml.net. And this is not a large language model, this is more machine learning. So in this particular example, so the ml.net supports a number of different machine learning techniques. This particular example is using semantic analysis, sentiment analysis. So it's going to look at the text, this restaurant was wonderful, and it's going to let me know, is that a positive or a negative thing? Well, it turns out that's a positive thing to say the restaurant was wonderful, that's good. So yeah, so you could use that to analyse responses to a survey, for example, and find out if people are enjoying things or not. Okay, so that was a really quick introduction to .NET. So now it's time for you to have a try yourself. So what I've got here is we've got some handouts with a whole bunch of links to all the different things you can do with .NET. So for those who haven't got it installed, we can help you get it installed if you haven't done that already. We've got tutorials on building web applications. So there's Blazor, Minimal API, MVC, SignalR. I've got ones on the desktop apps. Obviously WinForms and WPF, you're going to have to be on a Windows machine. Maui will run cross-platform, but it may have some download requirements. So yeah, could be tricky. F# one, if you've never used F# but you're familiar with C#, maybe try that one again and learn a bit more about F#. And we've got the cloud one is .NET Aspire. I think that requires Docker, so could be tricky. The data one should be straightforward. You don't need a database, it just does it in memory. The AI ones, some of those should be okay. Some of them may require you to have an OpenAI model to talk to. The ML.NET one won't. The game one requires you've got Unity installed. That's a massive download, as I mentioned in the message I sent out to everybody a couple of days ago. If you haven't downloaded that before, then don't try now, because it's like 7 or 8 gig or something ridiculous. So, and the IoT one, unless you've got a Raspberry Pi in your backpack, that one won't work. So, but it's there, and if you've got a Raspberry Pi at home, then feel free to try that out later on. So I've got all those URLs printed out on pieces of paper. So we'll hand these out and give you a chance to have a try building some stuff. And if you run into trouble, just ask someone here or stick your hand up. Myself or some of the other organisers are happy to come around and give you a hand as well. So, cool.